Okay, so thank you all who have decided to keep continuing on. I'm really happy to see how many of you are choosing to do that. First of all, just a quick reminder here, as long as you turned in those first week's assignments reasonably early on, I know they're not due until tonight if you're seeing this Tuesday. If you turn those in a little bit early, they should already be graded. And just a reminder that you can always redo any of those questions if you want to increase your score on those. We've got office hours available on Tuesday from 9 to 10 and then Thursday from 1 to 2. So just pop in if you have any questions and want to redo any of those. That's no problem at all. So this week, we're going to be talking about the area of circles. We're going to cut off regular polygons and just focus on circles right now. And then while we're talking about the area of circles, we're also going to have to really quickly talk about the circumference of circles too. And so we're going to look at where the area of formula for a circle comes from, and then we're going to apply it to solve problems. And we're going to skip the area of regular polygons for now. So our first thing here we've got is just some vocabulary. We've got our circle here. And so we've got two really key words that we talk about with circles. The first one of those being the radius. Now the radius is just the distance from the center of the circle to the outside of the circle. That in there, distance from the center to the outside of the circle. And that's the line you're seeing in red. Now, you could measure that radius anywhere you wanted to. It doesn't have to be exactly where I have it drawn in. It could be anywhere. And what you'll notice here is because that circle is all those points that are equidistant from the center, it's actually all the same. Doesn't matter where we draw the radius, it's always the same. Next up, we've got the diameter, and the diameter is just the distance from the distance from one side of the circle to the other. It has to go through the center. So that's going to be the distance across the circle. And if you're noticing something here, the diameter is automatically going to be twice the radius. And so we just take the radius times 2 and we get the diameter. Next up, we've got a fancy word here, circumference. For circumference is just the word that we use for perimeter of a circle. And so if you ever see a circle, you're not going to see the word perimeter, you're going to see circumference instead. And just like with perimeter of anything else, that just means the distance all the way around the outside. And then the final one here is area, and that is just the amount of space. Same definition as any other shape for area. Now, for circles, you've probably seen these formulas before. The area formula for a circle is going to be that one where you've seen it's pi r squared, where pi is that 3.14 number, pi r squared. And then the circumference, or another name for the perimeter, we've seen two different ways. It's either going to be 2 pi r or pi times d. And the reason we can write either one here is just because if I take 2 times r, that's the same as d. Now I'm going to start here with what circumference is and kind of talk about what pi is really quick. A lot of times people are asking, how do we know that this circumference is 2 pi r? And it turns out that's actually the backwards way of asking that question. Rather than coming up with the circumference as a formula of 2 pi r, it turns out that pi itself is actually defined based on the relationship between the circumference and the radius, or technically the diameter. And so all pi is, the actual definition, mathematical definition of pi, is the circumference divided by the diameter of a circle. And that just happened to be a constant number. If you took that circumference distance and divided it by the diameter, you always get the same number, and it's pi. And so it's not so much that someone came up with the formula for circumference, it's actually that somebody noticed that when you divide the circumference by the diameter, you always get about 3.14. Okay, so let's go ahead and do some examples. Those are the only two formulas you're going to need. So the first one here is going to be just finding the area, or finding the circumference. And so we're going to start off with the area of the circle. So you're going to need a calculator for this one. And I'm going to show you two different ways you could leave your answer for these. But We're going to start off just like we've done all the other ones. I want to see your area formula. So area is going to equal pi times r squared. I'm going to start that over. That was not very good. Pi times r squared. And then I'm going to plug in what I know. Pi times 2.5 squared. Now, option 1 at this point would just be to type that whole thing into your calculator as it's written. So I've got my Desmos scientific calculator pulled up on the side here. And so I'm just going to type in pi times 2.5 squared, exactly as you see it there, including the parentheses. And when I do that, my calculator tells me that it is 19.63, and this is centimeters squared. We're talking about area here. Now, the other option is we sometimes like to leave these answers in terms of pi. And so to do that, all you're going to do is type in everything except the pi on your calculator. So just the 2.5 squared, which my calculator is saying is 6.25, and I could leave this as 6.25 pi centimeters squared. The nice thing about this one here is that this is an exact answer, whereas this one is rounded. And just like we were talking about when we were doing some of those, remember the Pythagorean theorem problems, we left those in terms of square roots, like 2 times the square root of 3 as an exact answer. This is an exact answer for the area, whereas this one we rounded. Okay, next one here is going to be the circumference of the circle. And so again, I'm going to start off with the formula. Circumference equals either 2 pi r or pi times the diameter. And I'm going to plug in, since I know the radius is 2.5, I'm using this one, 2 times pi times 2.5. And again, this would be a good place to leave this one in terms of pi. So I'm just going to multiply the parts together that I don't have a pi in. 2 times 2.5 is 5 pi. And so my circumference is 5 pi. Now remember, circumference is a linear distance. It's just a length. And so we just have regular old centimeters here, not centimeters squared. Okay, let's go ahead and take a look at our next one here then. This one's kind of working backwards now. We want to find the area of a circle with a diameter of 32 inches. And so if I draw this out, I know the diameter is 32, but if you look into my formula for area, do an area, not circumference, we've got pi r squared. The only problem is here, I don't know what r is. I know the diameter, but I don't know r. And so what we need to do is think about the fact that the radius is just half that distance. If the diameter is 32, r is going to equal half of that. 32 divided by 2 is 16. So at this point, the video is going to pause. Go ahead and find the area of that circle. Okay, so remember, if I'm doing these, I'm always going to be writing everything down. That's how I want you to show it on your homework. So we've got pi times 16 squared. And then again, I like to leave these in terms of pi, leaving it as an exact answer. So 16 squared is 256. And so I would just leave this as 256 pi. We're in inches this time, so that's going to be inches squared. And that would be the best way to leave our answer in terms of pi. Okay, I'm going to go ahead and show you this one. Now we want to find the area of a circle with a circumference of 25 meters. And so this one's a little bit trickier. We're actually going to have to do some algebra here. So we know that the circumference is 25 meters. We don't know the radius. And so we're going to actually have to start with this circumference formula. Circumference equals 2 pi r. And I happen to know that the circumference is 25. Now, if you look in there, the only thing I don't know is the r. And so I can go ahead and divide by 2 pi. Divide by 2 pi. That's going to cancel those out over there. And this is going to need a calculator. I'm not going to leave this one in terms of pi with the pi in the denominator. But I'm going to take 25 divided by, and I'm going to put this in parentheses on the bottom, 2 pi. And my calculator says that that means that r is about 3.97. And that's in meters. Now, once I know the radius, now I can go back and use that in my area formula. Area equals pi times 3.97 squared. And again, because this is a rounded number, I said again, I didn't tell you to say this first time. Because this is a rounded number, this one's not a real, there's no real good reason to leave this one in terms of pi. So I'm just going to go ahead and type that into my calculator. Pi times 3.97 squared. And my calculator is saying that that is 49.51. And this is in meters squared because this is an area. So the big question we want to ask today, since we're in geometry class, is where does this area formula come from? It's probably something that you've heard before, and one of the big things in geometry is we always want to ask that question, why? Make sure we're justifying our answers. So the question we want to ask is it possible to make a circle into any of the other shapes? So we've talked about rectangles, parallelograms, rhombuses, trapezoids, kites, triangles. Can we make a circle into any of those shapes? And officially the answer is no, but there is a way we can come pretty close and kind of show what the area formula should be. So here I've got a circle. I want you to think right now, what shapes do you think I can turn this circle into? There's actually two answers that could work here. Okay, so here's what we're going to do. We're going to start off by taking our circumference and laying it out. Next thing to think about would be, well, how long is that circumference? And we know the radius is r. That means our circumference has to be 2 pi r. And here's the part where we get into actually finding the area. If we cut this circle up, we're actually going to cut it into basically pizza pies here. I've got 6 of them. Now, again, those aren't any shapes that we've talked about before, but they look pretty close to a triangle, right? So what we're going to do here is we're actually going to rearrange these. I'm going to lay them all out. Basically, at this point, we'd have 6 triangles. And rather than leaving it as a triangle, it's actually easier if we fold these last 3 back up. So again, that's not really a shape we've talked about, but it looks pretty close to it. If we could imagine that these bottom and top pieces here were, these bottom pieces here and here were straight lines, that would be a parallelogram, and we would know how to find that. We'd know our height is r, and we could figure out how long this side is. But again, it's not really a parallelogram, is it? So here's what we're going to do. Rather than splitting into 6 parts, if we try more and more and more parts, it gets better and better and better. It actually becomes pretty much a rectangle. And so our height here is r. Sorry. So it looks like a rectangle. And the dimensions of the shape, the height is r. I want you to think about what this length would have to be. Okay, so if this whole length here is 2 pi r, then that means that just this part here would only be pi r. And so if we have pi r times r, I'll go back here at this point. If I'm taking pi r, which was my base, times r, well, r times r is r squared, so we get pi r squared. Now at this point, you're probably asking the question, can we really do that in math? And we can. It's an idea that you're going to talk about much later on. Moving into like pre-calculus is called a limit, and we can actually do that in math. It's kind of this idea of as these pieces get smaller and smaller and smaller, this thing will get closer and closer and closer to a rectangle. And so that's where the area formula for a circle comes from. For some reason I have that in there twice. Okay. So at this point, there's going to be some homework assignments or some homework questions on the Canvas page. You're going to be finding the area and circumference of some circles, and then also working backwards on a few where I give you the area or the circumference, and I'm going to ask you to work backwards to find the radius or something like that. Remember, we've got office hours on Tuesday from 9 to 10, and then on Thursday from 1 to 2. So hopefully I'll see some of you there.